Okay students, today I am going to discuss about the volumetric analysis. In this volumetric analysis, I am going to discuss about the second practical. What is second practical students? The reaction between the potassium permanganate and oxalic acid. What is potassium permanganate formula? You know very well. What KMnO4 is the potassium permanganate formula. What is oxalic acid formula? H2C2O4 dot 2H2O. It means oxalic acid containing of the two water molecule. In this potassium permanganate is a pink color solid only. Oxalic acid is a colorless solid only. Both are soluble in the water by using of the volumetric analysis. What is mean volumetric analysis? To identify the unknown solutions. So what happened there? We are going to identify the unknown solution concentration by using of the known concentration solutions. So one is unknown, one is known. By using of the unknown, we can find the known. By using of the known concentration, we are going to find the unknown concentration of the solutions only. So students, look at the when you go for the next slide, we got very clear idea, So what happened there? Here the purpose of experiment only to carry out the oxidation of the hydrated oxalic acid only. Do you know very well oxalic acid formula? H2C2O4. So dot XH2O. So this oxalic acid containing a water molecule. So what happened there? We are going to identify the kind of redox reactions. Redox reaction. Do you know very well students what is redox reaction? Reduction nothing but gaining of electron. Oxidation nothing but loss of electron only. By using a redox reaction, we are going to identify the concentration of the unknown KMnO4 by using of the known oxalic acid concentration only. Students, you know is there no KMnO4 is a self-indicator only. What is KMnO4 self-indicator means? You know when you go for the last year when you are dealing with so acid plus base titration is there, no? There you can add the phenol indicator. Sometimes you add the methyl indicators only. But this volumetric analysis, we are no need to add any indicator. KMnO4 act as a self-indicator only. KMnO4 act as a self-indicator. Students, you know this is equation very important. 2 moles of KMnO4 react with the 5 moles of oxalic acid at acidic condition. This is very important. These chemical reaction occur at the acidic medium. So whenever this chemical reaction occurs at acidic medium, here manganese changes from the +7 oxidation state to +2 oxidation. It means after this chemical reaction, manganese gain 5 electron. What happened? The oxalic acid is there, no? Oxalic acid, whatever the electrons gain with manganese, no? That is lost by the oxalic acid only. That is lost by the oxalic acid. Okay, students, so let's next slide is then here. Look at what is in. First, what is a titration? The act of adding of the standard solution in a small quantity to the test solution till the reaction is completed in terms of the titration. So what happened? You can see very clearly this is a stand only. This is called conical flask. This is called burette only. What happened? These students are just taking here. I'm just taking the here oxalic acid. I have just taken KMnO4 in the burette only. Remember burette in the KMnO4, oxalic acid in the conical flask only. So what happened? The oxalic acid concentration I know very well. So what happened when I add the drop by drop KMnO4 at fixed time? What happened there? You know very well is there no? 5 moles of oxalic acid can react with the 2 moles of KMnO4. What happened after end point? What you can see here the change in the color. By based on the change in the color, how much amount of KMnO4 consumes? Based on that one, we are going to identify the concentration of the KMnO4. Concentration of KMnO4. First of all, what is the redox titration? A titration which deals with the reaction involved in the oxidation reduction. So what I mean that you know very well is some chemical reactions, redox reactions on the bete. So some chemical reaction occur by the exchanging of electrons only, gaining of electron, loss of electron also. In this titration also you can see the KMnO4 is gaining electron, oxalic acid loss of electron. So this kind of titration is also called as a redox titration. This kind of titration is called as a redox titration. So firstly, what is standard solution? A standard solution is the known solution only. For suppose if you prepare one solution is there which is known. For suppose I just prepare the 0.1 molar oxalic acid, 0.2 molar oxalic acid, 3 molar is known. I know one concentration they will you know with that one. Remaining one is you have to find the unknown concentration. So standard solution means which concentration you know. What is the test solution? The solution which concentration we don't know. Actually generally KMnO4 concentration we don't know. We know the oxalic acid concentration only. So next one is the go for the one small is what is reduction. Old definition, what is the students? Old definition reduction at the gaining of electron. Oxidation at the loss of electron. So next one is then you can say the reduction also, you can say the removing of oxygen also called reductions only. Okay, gaining of electron reductions also, addition of hydrogen also reductions only. Addition of hydrogen also reductions only. We can see here the chlorine gains one electron, they form a Cl minus. So what happens here, gaining of electron, you know. So with respect to Cl is a reduction process. With respect to Cl is a reduction process. What is oxidation? So old definition, what is oxidation? Addition of oxygen is called also called as oxidation only. What students are the addition of oxygen is also called oxidation only. So what I mean there, the consider here Leo, you remember loss of consider here the loss of electrons also called as oxidation. Loss of electrons also called as a oxidation. So next one is for this type of iterations we require some chemicals, some operators also. We discuss the operators is burette is required, beaker is required, pipette is required, Bunsen burner is required, thermometer is required, conical flask is required, measuring cylinder also required. So remember here that these titrations we are carrying at 70 degrees temperature. So that reason only to measure the temperature we require the thermometer. Only in this experiment only we are using thermometer only. Then students remember consider the next one is go for next slide is there now. What we are taking here, we are taking the 250 ml of the conical flask, 250 ml of beaker they will give. So what happens in this one, you just prepare the one standard solution. You prepare one standard solution of the oxalic acid. They will give in the one more beaker KMnO4, which is unknown concentration. Sorry. So what happens there, the consider, suppose just consider they are taking the potassium permanganate. They said no here. So what happens there, the potassium permanganate is then sodium oxalate. Okay, oxalic acid is the sodium oxalate, 0.1 normal only. Okay, sulfuric acid also. One more point remember is that these chemical reaction occur in the acidic medium only. These chemical reaction occur in the acidic medium. In this chemical reaction, manganese oxidation number changes from the +7 to +5, +7 to +2. So next one is go for procedure. So what are the procedures they will take? Means students remember that initially first of all this consider like that is there, no, they will give the one solution, which is the unknown solutions only. We will prepare the standard solution. This is conical flask. Okay, this is pipette only. So we will prepare the standard solution. Procedure will explain one by one also. Look at the procedure. First, transfer 10 ml of sodium oxalate, 0.1 normal, 0.1 normal, 10 ml of sodium oxalate will transfer in the 250 ml of the conical flask. So you know the conical flask is there, no? That conical flask. So you can see here this conical flask only. This is conical flask only. So what happens in the after this one is after placing of 10 ml of the oxalic acid, immediately we had to add the 5 ml of the 6 normal sulfuric acid. The sulfuric acid already they will prepare, they will give. No need to prepare yourself only. Next one is what happens there now, they will take the sulfuric acid, will add oxalic acid and shake the solution. Will shake the solution and then we will heat up to the 60 to 70 books or some books they given 70 to 80 degrees also no problem. So what happens when you start heating, you can see very clearly by using a thermometer. With help of thermometer we can easily measure the how much temperature is required only. But when the titration, the hard solution is there, no, they will just always remember when you are titrating with the KMnO4 oxalic acid, you must take the hard solutions only. Okay, no? So what happens there, when you titration, what happens there, first initially if you take oxalic acid is colorless only. When one by drop is KMnO4 adding, this reaction will continuously. So what happens, the one drop of KMnO4 fall into solution disappears. Again drop will fast disappears only. So what I mean at the end point is there, no, the pink color is obtained for the pink color is gained by the oxalic acid. That is called end point only. So what I mean, continuous with the titration drop by drop to the color changes from the pink color to colorless one. So what I mean, whenever the oxalic KMnO4 we add to the oxalic acid, okay, no, KMnO4 color losses only. Up to what time is there, no, whenever all reactant completed, up to this will happen. So I'll explain. Repeat titration 3 days. When you are dealing with volumetric analysis, always remember you have to do for 3 times only. You have to do for 3 times. Okay, students, here you have to prepare the oxalic acid only. How you will prepare oxalic acid? First, they are given the question is there, no? In the question there is laboratory. Prepare 0.1 normal oxalic acid. What is normal formula? Gonna weight by equivalent weight into 1000 by V. That is also one formula. Or else number of gram equivalent weights by volume of solution. What is equivalent weight and the better consider the look at it. How much grams I don't know. So X by equivalent weight of the oxalic acid 63. So next, how much I want normal I want to prepare 0.1 normal. So by using this formula, I'm going to find the how many grams of the oxalic acid I must be dissolved in the distilled water. Students, remember when you are handling the titration, always remember prefer distilled water only. So 0.1 normal is equal to equivalent weight x grams by equivalent oxalic acid 63. So now I'm just want to prepare solution 500 ml only. So 500 ml by 1000. So how much I got, 3.15 grams only. Whenever they said the prepare 0.1 normal oxalic acid means you have to take the 3.15 grams of oxalic acid, place it in the 500 ml and stir the solution. That's nothing but a 0.1 normal oxalic acid. Next, what you're doing, the next procedure is there. Now look at there. What happened there? Warm the solution gently until we'll take the 10 ml of oxalic acid in the say a conical flask only. Then what will you know? We'll add a small 10 ml or 5 ml of sulfuric acid, and then what will do? We'll start heating one. We'll start heating. When you start heating, up to what time is there? No, you can see small bubbles will boiling up the water. You can see in the beaker only. Conical flask. Immediately will take that other hard solution. You go for titration. So what happens when you go for titration? What do you find here, students? Is that so? What of the reaction we observe here? The what reaction we observe means you can see very clear here. Initially, you can see the initially this oxalic acid colorless only. When you go for titration, you can see clear from here. What happened there? From the burette, drop by drop, KMnO4 is falling. Whenever KMnO4 fall into solution, KMnO4 disappears. Again, drop will come. Again, pink color will disappears. So until what happens means now we will get the one pink color only. Okay, now one pink color only. So this guy end point. So students, remember the when you once you got the end point is there, no, so you consider that roughly same will come only. Same will become for end point only. So this is the end point only. So once the solution changes color means you will take the burette, you will find the reading and you will note that one. You will be note that one only. So what happened there? One more slide. Initially look at you consider one by drop KMnO4 you will add. So next one is you can find is there, no, you will find the value of the volume of the KMnO4 is consumes. So by based on this volume of KMnO4 consumes, I will go for the calculation. By using of calculation, I can easily find the how much, what is the concentration of the KMnO4. Always remember, students, this equation is very important. They will ask most of time in the practical examination point of view. This equation you have to remember. You know very well, no? Consider, no, here what happened there, the 5 moles of oxalic acid react with the 2 moles of KMnO4 in the acidic medium. Look what happened, 5 moles of carbon dioxide, Mn2 plus water molecule. It's very important only. So what happened there, when you go for last is calculations only. Okay, no, we look at calculations. What happened there, no, you know very well is, no, how to measure the weight of substance is there, no. Okay, now you will go for calculation part, you will get the final result only. Regarding calculation part, we will discuss in the second video. So what happens, students, just consider this equation you have to remember. For calculation part is then here, this formula you have to remember, molar KMnO4 into volume of KMnO4 by molarity of oxalic acid into volume of oxalic acid 2 by 5. 2 by 5 you remember only. Okay, no? Molarity of KMnO4 into volume of molarity and volume of KMnO4. Molarity volume of the KMnO4. You know, molarity volume. So KMnO4 molarity is the solutions. You know, we are going to find that one is. Okay, no. So what happened? This one is you can apply this formula and you will finally get the answer only. So what happened? How many times you have to take readings are there? No, look at this by this column only. Starting point, end point. How much volume of the KMnO4 consumes? 3 times you will do that one is you will add the final result only. Regarding calculation point of view, we'll discuss in the second one only. So students, always remember how we are going to calculate is there. Now initially we take one watch glass, or also take some crucible there. You have a watch glass only. With that weight you will add. What is the weight of the watch glass? Amount of the oxalic acid, not more salt. Amount of oxalic acid. We add amounts of oxalic acid. We'll find the final values only. Okay, na? Final values you are going to find it. So first one is then here the what I learned. Potassium permanganate is strongest oxidizing agent. X of dilute sulfuric acid needed, otherwise it forms a brown color pipette only. So what I mean there, if you are not adding X amount of sulfuric acid, brown color pipette will observe only. Okay, no? Of the hydrated manganese dioxide only. It's very important, students. That influence observe only. So what I mean there, the oxidation and reduction is slow at the room temperature. So what I mean there, to make the oxide reduction is happen very fastly. That's the reason why I am increasing the temperature. That's the reason why I am carrying this type of the titration at the hot conditions only. Okay, safety precautions. What safety precautions you must be taken in this laboratory? can what happened consider the upper mesothelial to the upper meniscus layer. Look at what happened the K-upper is no K-upper color solution always you have to take the upper meniscus layer. For colorless solution you always take the lower meniscus layer. Handle the fast glass carefully. Look, when you're handling the glass, that glass whatever may be you're careful. Why means it will break easily. And just wear the gloves and what you know very well is when you are handling the oxalic acid, when heating the oxalic acid, you must take care. Why? Because means temperature is there. Okay, na? Temperature will be there. And next one is that here the look at consider the what is self indicator. I mentioned this word is self indicator. What is mean self indicator? Means you know where is here, as well as you know that one is potassium permanganate is a dark purple color solution, and it titrates to become to the colorless only. So when the titration is completed, what when they drop one the drop K1 for solution is what when the K1 for become to the color to colorless solutions only. Okay, no? This kind of which is indicated one is the reaction is completed. So whenever the pink color disappears, one endpoint pink color is coming means no that what happened then here you can suppose you can sometimes you will some student they will take in the reverse manner also. That time they have given. Okay. Next one is oxidizing agent. This is very, very important. Potassium permanganate is used as an organic chemistry in the form of the alkali or neutral solutions only. Oxidation, you know, oxidation of the addition of consider the oxygen only. So oxidizing agent which gives the oxygen atom. Oxidizing agent means which gives the oxygen atom only. So students, you will calculate and finally you get the look at by using of this calculation. This slide you can pass and you can see very clearly. By using of this calculation part is then we are going to find the mass of a substances. We are going to find the mass of a substance of the unknown solutions only. Okay, students, up to this one is there no oxalic acid versus K-of titrations only. Okay, students, thank you.